Hello everyone. Today we're gonna look at how to make a regression test. A regression test is a type of test that you can use if you have two numerical or continuous variables. So here I have an x variable that ranges from 0 to 10, but imagine that this could range from many different to much higher and much lower numbers as well. So it can vary however we want to. The other version, of course, is that you have discrete variable, a discrete independent variable, the x variable, that you can be in one group or another or something like that, but they have no numerical relationship between them. Continuous variables like this, it can vary numerically for over a vast range. And we have a y variable that's also continuous or numerical. Now, the first thing we need is, of course, to have our data analysis toolpack installed. So if you don't have that, you need to go and check how to do that. But let's assume that you have this already. We click this one again, like we did with the t-test. But here we're looking for a regression test. That's the one we're going to look for. So a regression test asks us how likely is it that if we take this y variable, the null hypothesis is that there's no relationship between at which corresponding independent value, x value, that this number is. So if we put these all together and make one single distribution, and we would randomly take a value from that distribution and put at any of these levels of the independent variable, how likely is it we will get this pattern that we see? And the alternative hypothesis is the one that we hope to be able to prefer, is that there is some pattern as to which y value we have at a given x value, if that makes any sense, that there is some kind of relationship between the y and x value. So if we click and select our regression test, it asks us to put in a y data value, a range of data values that correspond to our y variable, and a range of data that corresponds to the x value. And you note that Excel here likes us to have them in two different columns like that. So I click and select my y values, enter, and click and select my x values and press enter. And then this is all we need to do. You can also ask it to put some other things as well, but not necessarily. So click OK. Then we get our summary here. And okay, so what the test has done is applied a linear fit. So here we have the two for a simple linear equation. So the y equals kx plus m, where the constant here, that's our intercept or the m value. So that's the number where if you have x equals 0, what y value would we have here? And the x variable, that's the coefficient or the k in this. So any change in our along the independent axis, any increase in the by one step on the independent variable axis, the x-axis, how much change should we expect on the y variable? So this regression test then fits this function, the best function it can, and it gives a p-value here as well. So the probability of getting this pattern under the null hypothesis, and just like any other statistical test, we're looking for p-values that are below 0.05. If you have higher values than 0.05, it means that the null hypothesis is a 5% probability that the null hypothesis would have given a pattern like this, and we would not be able to discard or reject the null hypothesis. So in this case, we have a high or low probability for the null hypothesis, so we're happy to reject it. And it also gives us the R values. These come from a Pearson correlation, and it shows us the R square and adjusted R square. So that's the correlation that can vary between -0 and 1, where 1 being a perfect correlation, that the values perfectly fall on the linear equation. 0.7 is very high. So we can actually check this ourselves by doing, check how this function looks by going back to our data, selecting them and going to insert and taking a scatter plot here, inserting the trend line and looking at the trend line here, format it and show the equation in R square. So this shows us the linear fit. We can compare that to this one and see that it's the same one, 1.063, and the y is 6.045, yes, and the R squared is 0.79, and that's this one here. So those are the same. So this is just showing this calculation. So the important thing to look for, like we said before, is to look for this p-value. The lower that it is, the more likely or more improbable the null hypothesis is. If it's below 0.05, we can say that yes, it is fine to, by convention, to reject the null hypothesis and conclude that yes, there is some kind of relationship between the two variables. The higher this value is, the more the data follows this line. So imagine a perfect 1 value would be, a perfect 1 R square value would be that all the data points fall exactly on this line. So the more spread we have along the line, the lower our R square value. So basically what you want to report usually is the function, the p-value, and if you want to say something about how well the data, how much of the data is explained by this relationship, the R square value is important. I hope this helps a little bit. Please ask more questions if you want to, and then maybe I can make some more videos. So see you for the next one.